Testing audio. Testing. All right. It's good afternoon. I'd like to start about the audio and the video quality. Okay. Right. Okay. So, right. What do you say? Not clear. Audio. Right. So, okay. Okay. Right. We'll start. Okay. So last week we finished equilibrium of forces, right? We have finished equilibrium of forces, and now, as we planned, we are starting center of gravity today, right? Center of gravity is the next sub-lesson we have in mechanics, and when it comes to questions, it plays kind of a significant role. But good, okay, right? So therefore, starting from here, we'll be starting center of gravity from scratch, and this is not much linked to previous lessons. Therefore, not that much of a prior knowledge is required, right? So therefore, the regular batch is regular batch, not the regular batch, what we call the new batch. New batch is also joined to the regular batch today onwards, right? Okay. All right then, we'll start. Now it's okay. All right. Okay. That might be something from you, and I guess I haven't started recording. You should have heard me. Okay. Good afternoon again. Otherwise, the meetings are not going to be okay. Right. Take down the heading as another announcement. I have uploaded the past year questions of force equilibrium under week 5 of October. Right? So past questions are there. And now we can try all the questions. We'll upload the answers for the past papers in another like 3-4 days. Right? And next year onwards, you will be getting past papers itself printed on the table with the answers. Right? Now in center of gravity 1, Past papers are printed. Right? Okay. For line swells, those are already posted, so you will get it within 2-3 days. Right? For new batch students, you will get 2 news. One for the Newton's laws, the ongoing lesson on Tuesday, and the other one for center of gravity, the lesson here. Right? Okay. Those are things. We'll start it. All good? Right. Okay, let's start. Write down the heading as center of gravity. Center of gravity. Center of gravity. Right. Tell me, what do you know about center of gravity? What do you know about center of gravity? We just started. What happened? Yeah, that I know. I know. What happened? Huh? Right. So, what do you know about center of gravity? Have you done the homework? No. Huh? No. Right, okay. No, we intend the circle. This cat, right. What do you know about center of gravity? What line? Is it here? What do you know about center of gravity?
Point, they are the index full mass is acting.
Almost correct. Not the mass, but wait. Because mass cannot be. Mass is a scalar or vector. Mass is a scalar. Mass is a scalar. Right? So therefore, mass cannot be. Only the weight acts. Only the weight acts. Right? Only the weight acts. So therefore, center of gravity is the point where weight of an object acts. Right? Center of gravity is the point where, listen, center of gravity is the point where weight of an object acts. Right? For any kind of an object, there's a particular point, single point. The resultant weight acts. There is only a single point. There's a single point, the resultant weight acts. Right? Now, take this marker. Right? Now, this marker, somewhere inside the marker, there is a point. From that point only, the weight of the marker acts. Right? Weight in the sense resultant weight. Now, when we mark weight of an object, we don't mark weights as from all particles. No? We are marking resultant as mg or w. Right? The particular point where the weight acts is called center of gravity. Right? For any type of an object, for any object simply, the center of gravity is there. Right? For the marker, desk, chairs, laptop, for us even, we have our own center of gravity. Right? So we will discuss where our center of gravity is, the coming parts. Right? So basically, first idea you have to have is center of gravity is the point where weight of an object acts. Right? That is a single point. There is only one center of gravity for a given object. There is only one center of gravity. A given object, for a given object, there is only one center of gravity. What do you? Sorry?
For humans.
Humans.
Yeah.
See, there is only one point.
What is the
Yeah, still, even if there is change, there is only one point at a time. Only one point. That is a good question. Center of gravity can be changed, but still there is only one point at a time. Even if there is change. Now, again, if I explain using the same example of the pen, now if I take off this clip, center of gravity displaces by a bit. But again, still there is only one point, one center of gravity. So if mass changes, center of gravity changes. Okay. Write down first point under the heading. Write down the first point. The point where the point where the point where the point where weight of an object, the point where weight of an object acts, the point where weight of an object acts is called center of gravity. Is called center of gravity. The point where weight of an object acts is called center of gravity. Will you explain again? Listen again. For any type of an object, for any kind of an object, right? Any type of an object, living, non-living, anything, even for a particle, right? There's a particular point where its resultant weight acts. There's a particular point, a single point, from where its resultant weight acts. That point is called center of gravity, right? So therefore, starting from a particle to any massive object, there are center of gravity. For a given object, there is only one center of gravity at a time. There is only one center of gravity at a time. Center of gravity changes if mass changes only. Center of gravity changes if mass changes only. Right?
Doesn't it also depend on the shape?
Shape, no mass distribution. Now, when shape changes, if mass distribution changes, it changes. Got it? Now, even though my mass remains same, when I'm standing still like this, center of gravity is at the hip. Now, if I bend towards this side, center of gravity displaces towards it forward side. Right? So what matters is mass distribution. Distribution of mass. Right? So don't say shape, distribution. Right? Okay. Listen. So based on the position of center of gravity of an object, there are three equilibriums. Right? There are three equilibriums based on the position of center of gravity. Right? Where center of gravity is located with respect to the object. Right? Now let's see how center of gravity is located and with respect to the point, with respect to each point, how the equilibrium changes. Right? Right on the heading. Right on this heading. Equilibrium of an object. Equilibrium of an object. Equilibrium of an object. Equilibrium of an object with respect to center of gravity. Equilibrium of an object with respect to center of gravity. Equilibrium of an object with respect to center of gravity. Okay. Look at here. Look at here. Now, say this object is kept on a floor like this. Say on a table, this object is kept on a table like this. Right? When the object is kept, right, there is an area which is bound by the contacting points of the object. No? Is it clear? Now, if this is a box, there are 1, 2, 3, 4 points at the bottom that is contacting the table. Is it clear? Now, if I connect those points, that area is called supporter. Supporter surface. Right? Now, when this is kept in equilibrium, now there is a linear length here that is in contact with my arm. That is called supporter. Right? Likewise, for any object, if there is in equilibrium, there is a supporter. Now, if I get this one, see, now when this is kept on the palm, this whole area is in contact. That is called the supporter surface. Got it? Now, if I can keep this like this, we can't, right? If I can keep this like this, right? This becomes the supporter surface. Correct? That is the idea. Now, of this bottle, this circle is the supporter surface. Correct? Now, if I keep it like this side becomes the supporter surface. Correct? If I can keep it like this lid becomes the supporter surface. Likewise, the surface which is in contact with the usual object when that is in equilibrium is called supporter. Right? Now in this case, now I have drawn a 2D diagram. The length from here to here in this 2D diagram, this is called the supporter. This is actually a surface. Huh? So imagine 3 dimensional. Right? So that is called the supporter. Right? Okay. Then with this idea, come here. This is a surface, huh? This is a surface. If there is a linear object, it will be a what? There is a linear object, that is a line. Just a line. If there is a linear object, what are the linear objects here? Linear objects in the sense, say a thin wire is kept on equilibrium like this. Then there is no area, if there is a thin wire, right? So in such cases, that is a line. Otherwise, there is an area. So therefore, we call it supporter surface, right? Supporter surface. Right. Now, look at here. Now, this is a random object. Right? And this is kept at equilibrium on a surface like this. This is kept at equilibrium on a surface like this. Right? Say, center of gravity of this subject is inside the supporter. Now you can understand what support is, right? I'll mark the supporter identity. See, this is the supporter surface. Clear? If center of gravity and acting line of weight, listen carefully, is the first thing you are learning about center of gravity here. Except the definition now. But what I said was the definition before the introduction. Right? If center of gravity is inside the supporter surface, it's two things. If center of gravity and acting line of weight, right, are inside the supporter surface, that is called a stable equilibrium. Stable in the sense that is not going to topple or fall. That is a stable equilibrium. Completely stable. Right? So this is called stable equilibrium. I'll show you how this changes. This is called a stable equilibrium. Right? Now, if I do something like this on the same surface, now if I move this object to somewhere here, right, as its center of gravity is coming to the very edge of the supporter like this. Now, what is supporter surface now? Supporter surface is the surface which supports the equilibrium here. So only up to this point, because the rest is not in contact. Right? I clearly told you. Supporter surface is what is in contact. The surface which is in contact with the mutual body. So therefore now supporter surface is short. Right? It's short because we push this towards this side. No? Now it is shortened. Now only this part is the support. Right? Now if center of gravity, we usually denote center of gravity by G. Center of gravity. If center of gravity and acting line of weight is at the edge of the supporter, at the edge of the supporter, that is called a neutral equilibrium. Right? Practical meanings are there. I'll show you after this explanation. Neutral equilibrium. Right? Now, I'm going to do this further, like this. I'm going to push this further like this. Like this. Right? And now the supporter surface is here. Up to this point. Right? And center of gravity is shifted outside the support. Now there is outside the support. Center of gravity and acting line of weight. Right? So when I say center of gravity, always that is like acting line of weight as well. Right? Now what happens is with this force moment creates, it is going to topple. It is going to topple. It is going to collapse. Right? This thing falls. This thing falls. Right? This thing falls out. This topples. So this is totally unstable. So therefore this is called unstable equilibrium. Unstable. We can't keep the object like this. Unstable equilibrium. Right. Okay. Now, before taking this down, if needed, you can take this down as a note and then take this down. And we'll be writing points under each equilibrium. Right? We'll be writing points under each equilibrium. Manage your stress. Right?
Why is the last one for equilibrium if it's not?
That's a good question. Now, even though this is defined as an equilibrium, that is not an equilibrium. Right? Unstable equilibrium means inequilibrium. Unstable equilibrium means that is actually inequilibrium. Right? But we say unstable equilibrium. That is actually not an equilibrium. Unstable. Right? Yes, right? Right. Okay. So you are going to have this school vacation this Friday. This Friday. Yeah. This Friday. Yeah, this Friday. Yeah. And 25 batches going to start their exams on Monday. At 8:30 a.m. Pure maths. Physics first is on 14. Second is on 17. Right? So 25 batches already gone now. Right? I mean, they are already gone. And in another 9 months, 26 batches taking for the exam. Since they are going to have the exam in October, as they say. So you are going to sit for the exam in next August. Right? 27th August. So it's not a huge time remaining. So always you have to learn these things and recall these things in a weekly basis. Right? Weekly basis. Otherwise, if you just start working targeting a term test or something, that is never going to work. Right? Even though the effort is small consistent effort matters. That's a key, that's a magic behind A-levels. Right? 25 students, no. Right? So especially when it comes to grade 13, second term, third term, there are students who are emerging from the behind ranks, from the ranks like say 50 students are there in the class. Now from 30s, from 20s, there are students who are emerging to top 5, top 10. The reason is they have worked consistently from the beginning. And when time passes over the time, they have gotten their knowledge and they are emerging, they are coming out, That's the thing. Otherwise, if you target a term test and work, that will work for the first term, or sometimes not only for the first term, not for the first term even. Right? First term may not be but more, right? Maximum you will go through the first term. It was there. Because always when the workload increases, consistent work matters. Right? So put a small consistent work. Put a small consistent amount of work. Do a small consistent amount of work. Did I explain you one day? Small consistent effort? I explained, right? That's it. Did I say it for the new batch students? Did I? The impact of small consistent effort. Didn't. Okay, something like this, I'll explain it in a free time. And another thing that I wanted to say is because now you are having the vacation, right? Listen, since you are having the vacation, I'm planning to conduct few more question discussions, right? So therefore, get ready. Tell yourself with the previous things we have done, right? The online discussions, online question discussions, because you are going to have the vacation, and I'm also kind of free because 25 days classes is over from this week. Now it's already over because last day was 4th. Now today is 7th, right? 7th. So last day was 4th because 1 week before the exam we had to stop all classes, right? So therefore my 4-5 slots are available now. So I'm going to utilize that time for 26 and 27 batches, right? So therefore few question discussions will be rolling out. Make sure you are going through everything and preparing yourself, making yourself comfortable with the theory parts, with the questions. So other than the questions we discussed in the class, focusing the past paper, MCQ types and essay types, I'm planning to conduct a few more question discussions, right? Okay, as common discussions, as an example, we haven't had a question discussion for linear motion, projectile motion, right? No? So, yeah. For measurements we did. For linear motion and projectile motion, we haven't had that. Right now, as an example, I'm going to take a single day for linear motion and projectile motion. I'm going to discuss past application types, MCQs, and essays. Right now, for the new batch also, those lessons are over, so we can have the session as a common session. That's why. Right? So therefore, we can have it as a common session. Probably it will be in a night time. Probably, right? Or in a morning time. Right? Night time or in a morning time. Dates are not fixed yet, right? I'll inform all the things so I go to the chapters. Okay, finish? Yes. First video. Yeah.
The questions are
In first one, we read in the class. The first one. For this time, no.
No, reading in the paper after that you discuss.
Yeah, I got the session only. No, I sent you the paper like 1 or 2 days before, right? Yeah. I sent the paper 1 or 2 days before, and then you can try it out and come to the discussion, right? Without taking a time for writing, for trying the question in the class, right? For the second discussion also, we will do the same, right? That is good, no? Right? Okay. Sorry. This one. Write down below. Write down below. Below the first one. No? Below the first diagram. Below the stable equilibrium. Write down. These points are relevant to each diagram like this. So below stable equilibrium, write down. If center of gravity. If center of gravity. If center of gravity slash active line of weight. If center of gravity slash active line of weight if center of gravity slash active line of weight is inside suborder is inside suborder is inside suborder inside suborder, it's called a stable equilibrium. 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 Right? Underline or highlight inside suborder. Underline or highlight inside suborder. So we didn't discuss the answer for it. Yeah, I can remember. I'll be discussing those questions also along with that question discussion we are going to have, right? That I have in mind. Thanks for reminding me. Okay, under the second one, neutral equilibrium, write down. If center of gravity, if center of gravity, if center of gravity slash, if center of gravity slash active line of weight give me 1 second. I don't I share the live channel. Very nice, good. That is fine, that's available. Did you notice the thumbnail I have to the YouTube video today? That is all about center of gravity. Right? You will understand what I meant at the end of today, by the end of today. There is an actual one, no? I mean, there is a doable, a practical, actual one. That's scenario. That's one. Balancing stocks. Have you done? That is one, just one application of center of gravity. And that equilibrium, that balancing is totally based on the position of center of gravity. Right? That is right. All right. Alright. So did you finish the second one? Finish? If center of gravity for acting line of if center of gravity slash acting line of weight is at the edge of the supporter. Is at is at the edge of the supporter. Is at the edge of the supporter. Edge of the supporter. It is called neutral equilibrium. It is called neutral equilibrium. Underline or highlight edge of the supporter. Edge of the supporter. Under unstable equilibrium, if center of gravity slash acting line of weight, if center of gravity slash acting line of weight, if center of gravity slash acting line of weight is outside the supporter, is outside the supporter, is outside the supporter, is outside the supporter, it is called unstable equilibrium. It is called unstable equilibrium. It is called unstable equilibrium. Right? Underline or highlight outside the supporter. Right? So likewise, with respect to the position of center of gravity with respect to supporter, the equilibrium of an object changes. Right? With respect to the position of center of gravity, equilibrium of an object changes. Now, as an example, what I meant, look at here. Say this one, right? Now, when this is kept on this palm like this, right? Everybody can see this. Okay, say this one. This one. Now this box is kept on the palm like this, right? Now, one more thing. If an object is symmetric, listen. If an object is symmetric, its center of gravity is at the center. Center means that is at the point where symmetric lines are intersected. Center is that. Center can name. Right? Center of this object is where the symmetric lines are intersected. So therefore, for sure, I know this center of gravity is around the center. There can be a slight change because of these things. Is symmetric now, right? Otherwise, unless otherwise, this is around the center. Now, when I keep this on the palm like this, right? Now you know center of gravity is somewhere in the middle. Now this is center of gravity and acting line of weight is imagine the acting line of weight W like this. Imagine the acting line of weight W like this. Alright. That is inside the border. So therefore this is stable. Nothing is going to happen. This is totally stable. Totally stable. Right? Now, if I move this towards this side a bit, see, at one point, center of gravity is coming to the very edge of the border surface. Right? The reason to say it's neutral is because if this is shifted to this side by a bit, it comes to the stable equilibrium. If that is shifted to the other side by a bit, it goes to unstable equilibrium. Right? Exactly in between, there is only one point as neutral equilibrium. There is only one point. How many stable equilibrium points for an object? How many stable equilibrium points for an object? Answer my questions. How many points for an object that it can be in stable equilibrium? For this object, let's say, for this object, tell me. Online? Yeah. Many. A beta wave, it's infinity. It's infinity. There are infinite number of points that it can be at equilibrium, right? Like this. Points here, there are infinite number of points, right? How many unstable points for an object? Infinite. Infinite. Unstable points are also infinite. How many neutral points? Only one. Only one. That is a beauty. Only one neutral point. Because if this is shifted to this side, that is stable. Other side, that is unstable. Right? So therefore, only one neutral point. Therefore, for our questions, for our sums, this equilibrium is very much important because when calculations are given, it is given to neutral equilibrium because that is the only fixed point we can consider when we consider equilibrium. Fixed and the maximum point. Now, if I say stable, how many points we have to and we can consider? Infinite. So therefore, we can't narrow it down to a single point and do a calculation. But in neutral equilibrium, there is only one point. Therefore, most of the calculations are given for neutral equilibrium. Right? If there is an equilibrium, if something comes with an inequality, range can be given. If not, that is only for neutral equilibrium. Therefore, this is playing a vital role in the coming parts in question. Right. Now we were here. Look at the board again. We were here at which equilibrium? We are neutral equilibrium. Right. Now, if I displaces this further, right? If I displaces this further, what is going to happen is this center of gravity is going to jump outside my suborder. But now, if there is jumping outside suborder, see, it falls. That is stability. Right? So therefore, based on the location of the position of center of gravity, based on the position of center of gravity, equilibrium changes. And those three equilibriums are stable, neutral, and unstable. If you need to keep something in equilibrium, right, you have to stick to either stable or neutral equilibrium. Right? In neutral equilibrium, there is a last point of stable equilibrium. Right? If you jump a bit, if your center of gravity jump a bit to the other side, it becomes unstable. Right? So therefore, usually when we keep something in equilibrium, always we are keeping it in the stable equilibrium. Right? If we don't have any special requirement, that is how we keep something in equilibrium. Now say now we are keeping this phone on a surface. Right? We don't keep it like this, no? Yeah, we don't keep it like this, no? This is a neutral. Usually how we do is this. That is stable. So naturally, what you know is a stable equilibrium. Right? Now about this desk. Right? Now when this desk is on the floor, that is in the stable equilibrium. Right? So therefore, naturally, what we do is the stable equilibrium. Unless there is a special requirement. A special requirement means if we need to say intentionally I need to elongate this to this side for some purpose. So in such kind of case, we'll be doing this. Like unstable means that is totally unstable, the system collapses. It falls down, it topples. Correct? So that is how it changes with the position of center of gravity. With the location with the position of center of gravity. Is it clear? Any questions up to here? Doesn't the number of equilibrium points depend on the object it's kept on? Doesn't the number of equilibrium points depend on the object it kept on? No. Even though there is a small one, still there are infinite number of points. Right? Say this is 1 meter long. Then how many points from 0 to 1 meter? Infinite. Say this is 50 centimeters long. Still, from 0 to 50 centimeters, there are infinite points. Correct? So therefore, not a problem. Got it. Okay, good. All right. Then this is a conclusion here. Listen, this is a conclusion here. if we need to keep an object in equilibrium, tell me, if we need to keep an object in equilibrium, what are the equilibriums we should use? Either stable, obviously stable, or neutral is also fine, because at neutral equilibrium also that is actually in equilibrium, right? But if center of gravity and acting line of force, the wave, not the force, acting line of wave jumps outside the border, it falls, right? It falls. Make a the end of that. This falls down. At the end of that, this falls down. This falls down this way, right? Make the end because this is drawn. Otherwise, it falls. This falls. Make a band. Make center of gravity. Make now make what is it? But it, because in this pen, this side is a little bit thick, no? Right? Can you see? That's another center of gravity. Down you turn. Right. Okay. Right. Write down below with the red pen. Right? With the red pen. First point, asterisk mark. Write down. In order to keep an object in equilibrium. In order to keep an object in equilibrium. In order to keep an object in equilibrium. Without toppling. Without toppling, you know the meaning, right? Toppling. Without toppling. Slash falling. Without toppling slash falling. Its center of gravity. Its center of gravity. Its center of gravity should be. Its center of gravity should be inside the supporter. Its center of gravity should be inside the supporter. Its center of gravity should be inside the supporter. Right? Second point, keep using that pen. Second point, keep using that pen. The requirement to be satisfied. The requirement to be satisfied. The requirement to be satisfied. To fall an object. The requirement to be satisfied. To fall an object. To fall an object. By being unstable. By being unstable. By being unstable is. By being unstable is. Center of gravity. Center of gravity. Being outside the border. Center of gravity being outside the border. Center of gravity being outside the border. Center of gravity being outside the border. Next point, keep using red. Next point. The minimum condition. The minimum condition. The minimum condition to be satisfied. The minimum condition to be satisfied. The minimum condition to be satisfied by an object. The minimum condition to be satisfied by an object. To be in equilibrium is. To be in equilibrium. To be in equilibrium is. To be in equilibrium is. Center of gravity being. Center of gravity being. Center of gravity being at the edge of the supporter. Center of gravity being at the edge of the supporter. Center of gravity being at the edge of the supporter. within brackets neutral equilibrium. Within brackets neutral equilibrium. Right. Within brackets neutral equilibrium. Okay. Any questions so far? All good? All right. Is there only one unstable equilibrium point? No, infinite. That is also infinite because any point after neutral point is unstable. Any point after neutral point is unstable. That is also infinite. Correct? So starting from here, all these points are unstable. Right? All these points are unstable. Starting from here. Right? Okay. Right. Isn't? Since I didn't explain about this for the new batch, I'll explain this again. Otherwise, I think I have explained in this class about this importance about the small consistent effort. Right? I showed you a mathematical example that day. Right? You were there. You were there. Right? A mathematical example, something like this. Now, as an example, our whole level journey is about 1000 days because that is 2.5 years. Right? Our whole level journey is 2.5 years. Right? I didn't do the exact numbers, but for the ease of calculation, I'm going to approximate this to 1000. Right? 365 times 365 is also 730. 730. Then another half means around, yeah, it's close to, very much close to 1000, no? Right? So therefore, usually if you have started your A levels just after O levels, right? Usually the time duration you are getting for A level journey is 2.5 years, right? Roughly 1000 days. That is actually a bit less than 1000 days. For the calculation, I'll be considering it as 1000, right? Something like this. Now let's say you don't do any effort at all, and you are just attending classes, right? You don't put any effort at all. You are just attending the classes and listening to all the things that I'm saying in the class and completing the note, going home and keeping the book aside until the next week. You are not putting any effort at all, right? Say that is 0 as a mathematical value. Your effort is 0. Simple as that. Your effort is 0, right? So with this 0 effort, if you continue this 1000 days, 0 into 1000, 0, 0, 0, likewise, something like that. What's the answer? 0, right? It's 0. It's 0. It's 0, right? And let's say I denote the amount of the degree of effort that you put by 1. Right? Mathematical, so I'm going to denote your effort by 1. You are putting an effort of 1. Right? This is just the amount. The value is used just for the sake of showing you this. Right? So assume that your effort is 1 equal to 1. Compared to 0, now we are doing something that is equal to 1. Right? And you continue to do this for 1000 days. What is the answer? What is the answer? Is the no. Online? Sekarang mungkin mereka kan it's 1. It's 1. Any power of 1 is 1. Right? Any power of 1 is 1. So this is 1. Right? So it is like now, when come back around, this is your effort. This is your effort. and this is your result. Right? Something like that. Now, if you put some effort consistently for 1,000 days, you want to fluctuate from there, right? If it is fluctuating, like if you are just targeting a term test and if you are doing something, right? It is like you are at 0 for the whole term, right? One term is usually 3 months long. For over 3 months, you are at 0, and suddenly you are doing something and taking a high, and again 0 and taking a high. It's fluctuating. And if you average it, the average is very low. If you average, peak points are within average, average is very low. So therefore, always consistency matters. Consistent. That is a keyword here. Consistency matters. Even though you are small, if your effort is small, you do it consistently, it matters. That is what I need to highlight here. That is why targeting the term best and working for years is not going to work out here in the years. Right? If you have elder brothers and sisters, ask from them how they work for their exams. Right? We can't do this just 3 months before the exam, last 3 months before the exam. No. The reason is that, right? Always, all these subjects are in science stream are made to have a consistency, right? So therefore, when we have that consistent effort only, we can go. Otherwise, there's no any magic behind this, right? In those good results. The reason is this, right? Now, with the O-level mentality, if you try to target the term test and if you try to study, that is not going to work. There is a main difference between these two, right? When we work consistently like this, term tests are just a point, just a milestone that is needing along your way. So therefore, you don't need to do something specially targeting the term test. Automatically, you will do the term test with the things you have done, right? Now, targeting the term test, you can increase the effort, but even if you do nothing also, you will score in the term test because you have done everything consistently. Got my point, right? Now let's say you are increasing your effort compared to one. You are increasing your effort by a small amount like this, and you are working for 4,000 days, right? I can't simplify. Tell me the answer. What is the answer? What is the answer of this? Therefore, that use a calculator. 1,000 power mega conversion like that. 1.001 to the power 1,000, not 1,000 times, huh? 1,000 times, to the power 1,000. What's the answer? Tashi 2.72. Is it? 2.72. Can I get there? 2.72. Right. 2.72. Right. See, now compare to this. Compare to this. Now here, difference is 1 million, right? Compare to this. Now you have increased yourself. You have taken yourself to some level that is 1.72 degrees higher. Right? No difference here. Right? What do you have to then? Compared to one, you increase your effort by 1 over 1,000. 1 over 1,000 I can increase. My increment is 1 over 1,000. Compared to 1. 0.01 is 10 to the minus 3, 1 over 1,000. Now you have increased your effort by a small bit. Right? By a very small bit. So see, this is not even double, no. More than double. Approximately maybe triple and got the point? Right. Now you are increasing your effort a little bit further. Say now you have increased your effort by 100 times, 100 times, 100 means 1 over 100 times. by 1 over 100 times, then this is 0.1. Right? 4,000 days. What is the answer? 27 point. No.
20,850.
27, never not 5 7 I the power.
20.
20. Sure. I sure. Let me get 20. 959. Yeah. Okay. 20,959. Right? See the difference? See the difference? What's the difference? Tell me the difference. Around 20,956 difference. Right? You increase your effort by another bit, but you work consistently for 1,000 days. Right? That is impact. That is impact. Right? If you 1.1 number, if you increase your effort by 10 times, 1 over 10, okay? 1 over 10 times. 20,000, yeah. Huh? Yeah, second. Yes. 10 to the power 41. Okay. E 41 then. 10 to the power 41. E can what is that? Don't you know what E calculators? Capital E, not simple E. Simple E that's a different thing. Simple E is exponential function. Capital E equals to capital E के then मैं value क्या होना पता नहीं था. Capital E क्या? Right? मैं value try करना. Capital E in calculators equals to 10 to the power. The number after E is the 10 to the power. We need 10 to the power. Power of 10. This is power of 10. Now, if you are getting E 41, which means that refers to 10 to the power 41. Right? Okay. That is what E means. Right. So, make numbers here known as this 10 to the power 41. Right? Yeah, 10 to the power 41. See how big that number is? Right? Make a one there. Right? See how big the number is? Right? So, that is impact. That is impact. Always small consistent effort matters. It matters. For example, since you are doing a sexual subject, principle based subject, right? Particular subject and physics. So that's why I thought this way, right? So it grows exponentially. Exponential growth it grows exponentially. Now, if you plot this, over time, you plot this effort over time, it grows exponentially like this. Right? That is what happens. So therefore, start working and keep your consistency. Maintain your thing. You have to maintain. Fluctuate no kadane. Dore average. Fluctuate kala average kala baana. My numbers on. Now what I'm just taking a may just for 3 days kala understand. Just average kala baana. Put number 2 number. Once you take the average for 1,000 days. Right? That's why. Therefore, keep this in mind. And even though your effort is small, do it consistent. Right? Then it will compound. Compound interest it will be compounding. Compounding it will be compounding. New work for the 500th day. Right? 500th day. Which means you are going to start from zero again. You are at a certain level. And starting from 500, you are working on the 500 first day. 500 not 500 first. But that is why it is compounding. compounding per tapping. Okay, that's enough. That's enough. Okay, now listen. Okay, see. Right, see. Since there are new batch students also, I will quickly brief about force moments again, because here we need to have some idea about force moments, right? Okay, you tell me what is a force moment? Force moment. What is force moment? Force into perpendicular distance. This is called a force moment. This determines what? This determines rotation of an object, right? About the rotation of an object. Therefore, force moment is denoted by, that is also G F times D, right? This is called the force moment. This is called the force moment. Now, as an example, let's say this force is 5 newtons applied 5 meters from point say A, from point A. Then force moment about point A is GA. Direction of force moment is the direction of rotation, right? Direction of rotation. Now, when this force is applied downwards, it rotates the object in anti-clockwise direction. So, therefore, direction is the direction of rotation. F into D, 5 into 5, this is called 25 Newton meters, right? And let's say I need the force moment from this force about point B, that is located 8 meters away, then that force moment is GB. But direction of rotation is opposite. Can you see? Now, if you think of B, the easiest way is keep a finger on B. Keep your finger on B and assume that, imagine that you are dragging this out from this force. Dragging from this force. See, when this is that, it rotates in clockwise direction. So, therefore, GB is clockwise. Its value is 5 into 8, 40 Newton meters. This idea is called force moment. If an object is in equilibrium, counterclockwise force moment and clockwise force moments are equal, right? So only that idea is needed here in center of gravity. Only that idea is needed here in center of gravity, right? If something is in equilibrium, anti-clockwise and clockwise force moments are equal, right? And about the resultant of an object, there is another principle coming from force moments that you are learning today itself. But this is the only part we had from force equilibrium, right? Okay, since there are new batch students, if needed, you can take a note. This thing.
There's no center, there's no gravity.
There is no
There's no gravity.
there is no center of gravity.
No. Because gravity only we can connect it. There's no gravity.
It means center of gravity.
Center of gravity.
Center of gravity. Yes, that is true.
So, okay, objects proper over there's only a gravity or center.
Because if there is no gravity, there is no weight. There is no weight. There is force time.
So, how things expect like apart from that?
Because of the gravity of Earth. Earth gravity is there. The only point we can leave, we can escape the gravitational field is infinity. Until infinity, even though it decreases, there is a value. Non-zero value is clear.
So, astronomical they are like
Floating effect. Moving, that is totally based on that circular motion. Orbital effect. Orbits are circular motions. Circular motion is totally done by using gravitational force between the air shuttle and the Earth and the Earth.
So if we keep something in space, like a scale, it won't stay there.
It won't stay unless it's having a circular motion. All stars, all planets, all meteoroids, asteroids, everything rotates to gain that. Right? Circular motion. So in circular motion, we discuss about something called centripetal force. To create centripetal force, there should be a rotation. Space right? Rotate. That is what is called launching another making yarn. Elon Musk last year what? Satellites. Launching satellites. That is what is called launching satellite. Satellite should be taken to the required orbit and the required velocity should be given there. Then only it starts rotating. Then that the mother spacecraft can come back once that is released. Coming on back. Orbital pattern. Any satellite it should be manually orbited. Right? If I need it, say at 2 kilometers above, then at 2 kilometers, we can calculate this speed required with an equation. Then we have to launch it there at that point with that speed. Then it keeps rotating.
So even there's no gravity, then there is center of the thing.
Repeat again.
Even if the place has no gravity, the thing will have a center of gravity and it will move. Because the rotating.
Because mg is coming from g, no? If g is 0, there's no mg. For centripetal force also this matters. Rotational motion means circular motion this matters. Wave force right?
So
Yes.
then there is a small amount of gravity in the space.
Gravity decreases with the distance away from the Earth's surface. Now at Earth's surface only there is 10. Right? So at 300 meters if we check, that is 9.79, something like that. Right? Further than that, it decreases. So likewise, until infinity, it is decreasing in this type of again, there is something in gravitational fields. G is actually called G dash. It decreases from Earth's surface to infinity like this. And finally, it's theoretically reaching 0. If we can go up to infinity. Correct. So therefore, if there is no gravity, it's nothing because there's no mg. Right? There's no idea about center of gravity because there is no weight. If there's no weight, there's no center of gravity. Right? Simply, if there's no gravity, we can't live anymore because Earth itself will be exploded. Earth again, gravitational force with the sun and all that. Right? That is why Earth rotates. That is why it rotates and it's going around the sun while rotating around the Earth. Earth means on axis itself. Right? So gravity nothing here. This whole system will collapse. Or Big Bang right? Big Bang right? Okay. Now the idea we need to have here onwards is this. Okay, as I didn't write down, principle of force moments. Write down. Principle of force moments. 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 Right. Something like this. Listen. Listen. Force moment caused by or force moment due to, listen now. Something like this. Force moment due to, don't write. Resultant. Postponed due to resultant. What is resultant? That everyone knows. Resultant is a single vector, a single force. If that's a force, a single force, a single vector to replace and represent a system of vectors. Right? That is what we determine in vectors. In vectors, vector angle, vector parallelogram, right? Vector additive law. That is all about resultant. So this force moment due to resultant equals, this is called the principle of force moments, equals sum of, don't write, sum of force moments due to each force. Right? I'll show you a practical example here. Force moment due to resultant equals sum of force moment due to each force if there are multiple forces. Because now, even though I consider the resultant is just to replace all the forces acting on this thing now. So let's say now 4 forces are acting here, right? And the resultant is only single force. Now always resultant should be equivalent to those single 4 forces. No? Single resultant should be equivalent to those 4 forces. No? So therefore, there is equivalent. This equilibrium is unharmed. There is unimpacted. There is unharmed. Therefore, these two are equal. Force moment due to resultant is equal to separate force moments, individual force moments due to each force. Right? First take this down, then I'll give you something in numbers. Principle of force moments. And highlight this. And I didn't notice. Yeah. Ashwi, how did you manage today? Because you said you are coming after school by 4:30 or something like that, right? Yeah, I saw you were there in the beginning and I forgot to ask. Are you also going to have the holidays, holidays means vacation starting today? No, right? It's different, no? Your timeline is different, right? No. Right. Okay, please. This idea is like this. Something like this. Look at here. Say, look at here. Say, two forces are acting on this rod. Two forces are acting on this rod. 10 newtons and 20 newtons. Right? And length of this rod is, let's say, 3 meters or 6 meters. Let's say. Length of the rod is 6 meters. Right? And I'm going to ask, say this is AB, yeah? This is AB rod. AB rod. And I'm going to ask the distance to point where the resultant force acts on this rod. Right now, just by using your knowledge, tell me if this is 10 newtons and 20 newtons on this uniform rod of 6 meters, right? Uniform rod of 6 meters, say this is a light rod, then that will be a light rod. For the explanation, no? A light rod. No mass plus. Right. That is why I have marked mg. Tell me, if only these two forces act, where is the result? I mean, what is your idea about the result? Is it at the center or to the left of the center or to the right of the center? What is it? At the center. Use your knowledge on vectors. 2 meters. 2 meters from from B. Right, to the right. Yeah, that is actually to the right. Because higher the force, resultant is closer to that heavier force. Right? So even if you don't know, you are learning this today. I just asked before doing the calculation. Calculation then you will learn it today. Just know that higher the force, closer the resultant. Higher the force, closer the resultant. Now, if it was 10 and 10, that is exactly at the center. Right? If it was 10 and 5, that is towards the left. If there is 10, 20, towards the right. If it is 100, 100, still at the center. Right? This is what happens when making the equation. See? Now, without knowing anything, listen, this is a new idea. Without knowing anything, now I'm going to mark the resultant force somewhere here. Now, as a value, what should be the value of resultant? That we can guess. What should be the value of resultant of 10 and 20? 30, because they are acting towards the same direction, parallel. So, resultant value should be 30. That we can say for sure. Right? That we can say for sure. Right. Now, we distance from, say this is x from A. Say this is x from A. Right? Now, I'm going to apply this. See how this application is done. Force moment due to resultant. Now, when we consider force moments, we have to select a point. We have to choose a point. Right? Now, as a point of force moments, I will be considering A. Right? If you consider A or B, the result will be same. Right? Now, I will be considering A because I have marked the distance from A now. That's why. Now, if I consider A and I'm going to apply this. I'm going to apply this. Something like this. Now, this side is for the resultant. This side is for the resultant. Force moment due to resultant. About A. About A. Force moment due to resultant. Direction is clockwise that I have marked already. Force moment is force into distance. Perpendicular distance 30 into x. Got it? 30 times x. And when we consider force moments about point A, 10 newtons is neglected because it goes through point A. There is no perpendicular distance between 10 newtons and the considered point. Right? There should be a perpendicular distance in between them. So if this point is here, on the line itself, there is no perpendicular distance. So force moment becomes 0. Therefore, if any force goes through the considered point, there is no contribution. There is no contribution for force moment from such forces. Therefore, 10 newtons is neglected. But the only force remaining is 20. Then this side, 20 times 6. This is 20 times 6. 20 times 6. Right? Simplify this. 6 times 5. 5 times 4. Which means x equals 4 meters. X equals 4 meters. Right? Center of gravity is located 4 meters from point A. Which means that is towards right now. That is compared to center, that is at the right. That is at the right. That is the reason. Now, if this force was, let's say, 40 instead of 20, it will be more towards the right. Then make a 4 meters. Now, if you do the same calculation having the force 40, increasing the force up to 40, you will get something greater than 4 because it will be shifting more towards the right side. Simply, when the force increases, higher the force, closer the resultant to that heavier force, higher force, right? Closer to the heavier force. Okay, is it clear now? This is the idea we are using in this principle of force moments. Got it? Take this down. What about online students and especially the new batch? Any questions? Yeah, tell me. Towards? Because resultant is the force for the vector to replace all of them. No? That's why. Because now initially the rear side has been B. Now with the resultant also, that particular side should be heavier as same as before. Right? But I think forces equally divided. If forces were equally divided, they'll be equally divided. Now they are not equally divided. So direct bias. Online students, is it clear? Is that idea clear? Clear, good. So athlete, put a thumbs up. Now I know you are taking down the note. So at least put a thumbs up. Yeah, clear, good. All right, take it down. Right. Finish. Now here onwards, have this idea. Have this idea. If you can clearly see a heavier side for a given object, right? Always resultantly goes out to that heavier side. Right? So even if you consider these kind of forces also, the idea is same. If these two forces are F and F, resultant is exactly in between 45 degrees. Right? So this is a result of what? Vector parallelogram. Vector parallelogram. Vector parallelogram is a result of vector parallelogram. Right? So we know you can write this angle as tan alpha. That is F over F. F over F 45. Tan inverse 1 45. Right? Now if this was F and 2F, this will be more towards the 2F side. Got it? So this heavier side data now shifted. Like doesn't matter whether it's parallel or perpendicular or whatever it is, it shifts towards the heavier side. Right? Heavier side data. Okay. So this is less than 45. This less than 45. Less than 45. Correct? Something like that. That's the idea. Okay, linear connector because here we need this. This is actually coming from, this is not center of gravity. This is actually coming from vectors. This is coming from vectors. Right? Vector parallelogram. Parallelogram make equation parallelogram. Make equation approve as root x squared plus y squared. Right? That's all. Okay. Now a small task, listen. Before that, mention this point in red below. Mention this point in red. Mention this point in red. Mention the point in red. Resultant force. Resultant force. Resultant force. Resultant force. Always shift towards. Always shifts towards. Always shifts towards the heavier side. Always shift towards the heavier side. Shift towards the heavier side. So do we have to pick the same pivot when doing calculation? No. 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 Without considering A, if you consider B also, you will get the same. You will get the same. If you consider B, when you write this distance, you can write the distance as 6 minus x. Right? 6 minus x. Still you will get the same. Right? If lengths are known, you can pick any point. If lengths are unknown, we are restricted because we have to have length when writing correspondence. Otherwise, you can pick any point. Finish. Okay. Now this is a small task. See. 21. Say two forces are acting on space separated by a distance L. Two forces are acting on space P and Q. Two forces are P and Q acting on a space separated by a distance L. Right? Say this is A and B. A and B. right? I need you to find the distance to the resultant. Listen, I need you to find the distance to the resultant in terms of these given letters P, Q, and L from A and B. Take a moment, right? So I will label that resultant point as, right? For you is, so this is the resultant. Now as a value, what is the resultant? Value of resultant. Magnitude P plus Q. Magnitude is P plus Q. Parallel forces, no? P plus Q, right? And let's label the resultant point as G, right? Simply what I need is two answers for AG and BG. I need two answers for AG and BG, right? So apply the same and get two answers for AG and BG in terms of, listen, in terms of P, Q, and L, right? Should be in terms of P, Q, L. Right? You did right? You did right? A small task. Actually, the first task for the day. First task, no? You did right. And tell me your answers. Your lines of service. I mean, do we the same pivot for result and force movement and sum of yeah, that is a must. That is a must. Now, if you are considering point A when writing left hand side, for right hand side also that should be around the same point. May principle like a value right? This principle is it should be only around the same point. Now, if you are confused, see, this is only about or around same point. Only about or around same point. If you consider B, you have to write both sides around B. If you consider any other point other than A and B, both sides about that same point, right? Should be about the same point. Force moment due to resultant equals sum of force moments due to each force about the same point. Any answers? Any answers? Universal. Answers? G is a point. G is a point. G is a point. Brain has to start again, right? I think for Colombo it's kind of mild, but in other areas I saw some extreme conditions also. Colombo is kind of mild. What about others? Is it training for your areas? AG equals QLOB plus Q. AG. Correct. Good. What about your areas? Is it raining again? I mean, extremely. Is it extremely raining again? Yadushini, raining. Summer. Summer for Gambula. You are from Gambula, right? Candy or Gambula, as I can remember. It's winter here. Candy or summer? Winter. Distance is distance AG. Distance AG. AG means distance. AG means distance. Is a distance. PG means there is a distance. Gambula. Yadurshini, you are from? Okay. I asked because I'm planning to visit Candy tomorrow. For Candy or Candy is actually I'm coming to Tuskegee tomorrow. So it might be raining, right? Is there anyone from that side? I guess no. Yeah, Kampola I can remember. Alok, you are from Kadugastad, right? Right? Yes, same answer. Correct. Good. Remember them as AG and BG. Good. Okay, which means candidate training. I'm planning to visit Tuskegee site tomorrow, and I'll be there day after tomorrow as well. Because now 25 classes are over. I'm going to go on a trip. Otherwise, my days are fully packed. And now, for this month, it is kind of right now until revision classes are started. Revision classes will be starting the first week of December. So until that, we are like KD. That's why I asked. Okay, that's it. Yeah, so you have 10 correct answers, most of you. Have you good to say? Yep. What is so? Okay, see. So I will refer this length as AG. I will refer this length as AG. Right? And going to apply the same theory for point A. Right? Going to apply the same theory for point A. About point A. See? Going to apply the same theory about point A. Then force moment due to result at about point A is this distance is AG. Then P plus Q. P plus Q times AG. I will refer this distance as AG. Right? That's AG. Right? And if you are considering force moment about A, there's no contribution from B, from P. Coming from Q only. So Q times L. Only force moment is from Q times from the distance L. Right? So AG is AG is QL over P plus Q. Right? QL over P plus Q. How did you get R equals P plus Q? Because parallel vectors, they are parallel vectors, you can simply add up. First, vectors. Last week, not last week. Week before the last week, we discussed. They are parallel vectors, we can simply add it up. If they are unparallel, we have other rules like vector angle, vector additive, parallelogram. Right? If they are parallel, result is addition. Okay, next. BG. So if you need BG, do the same about point B. Now about point B, force moments are in the opposite direction. So therefore, should be like this. Right? About B, from B plus Q result, the distance is BG. And no confusion from Q across B, around B. And from B, distance is again L. Perpendicular distance is L. So BG comes as PL over P plus Q. BG comes as PL over P plus Q. Right? Okay. Listen. This is clear? Same thing that we did before. Now, we'll be taking this result, we'll be considering this result as a proved result here onwards. Right? I'll show you how we are going to use this as a proved result. We'll be considering this as a proved result here onwards in center of gravity. Right? This is called force dividing ratios. This is called force dividing ratios. Okay, so after taking this down, this one example, then take on the heading as force dividing ratios. Force dividing ratios. Force dividing ratios. What happened? Did you find a mistake?
Let's make it very equal. Yes, expert.
See, intention of removing R is plus Q. If we invent the answer. Otherwise, you will get a relation between X and Y. How many X?
Here, the y not x is it. So I got this one. Yeah, this is one. So this equal this. How it goes. Okay.
R is subjected.
Here.
R is subjected. R is subjected.
Okay. That is right.
That
That is also right.
was very equal.
We should do the same if your relation is there. One L cancel, say, wait, cancel that. One L cancel, L Q, L P, L cancel. ये cancel है, cancel को समझ लेना होता है. Very sorry. Cancel L is plus. But when you approach, there's no point of omitting R because R is a given term. R means P plus Q. R is known in terms of given values. Comment, right? Should come. Okay, look at here. Look at here. Force dividing ratios means now same thing. If we have two parallel forces, listen these keywords. If we have two parallel forces acting with the separation of L, acting with the separation of L, like this, right? Let's say AB and the resultant acts where resultant R acts at point G, right? At once we are going to use this as a proved result. Can you see there's a common part in these answers? L over V plus Q is common. L over V plus Q is common for both, right? This is what happens. There's a small pattern here. That's why we are keeping this as a proved result here onwards. We can apply this at once wherever you need to find a distance to the result. You need to find the distance to the resultant force from one end. Then you have two parallel forces, right? You can straight away use this. At once you can use this. Right? See, AG equals. This is the pattern. Total distance, total separation over resultant. Total separation over resultant. Total separation over resultant value. Right? Into, if you are finding AG, look at here, this is the pattern. If you are finding AG, P is connected to AG and resultant is also connected to AG, but Q is not connected to AG, right? It should be multiplied with that not connected force into Q. Got it? If you need BG, this thing is same, total separation over resultant times. If you need this side, BG, multiply it with the not connected force P. Got it? Make up the same thing. I will separate these parts because it's common and understood the pattern. See, identified the pattern. Got it? Wow, made action. When you find this distance, AG, Q comes. When you find BG, P comes. This is a proved result for two parallel forces. More than two, not bad. This is only for two parallel forces. Right? This is proved only for two parallel forces. So therefore, wherever we have two parallel forces, we can use this as a proved result. Right? Okay. Write down this and take this down. You haven't cancelled one then, or you have missed one. Yeah, otherwise it should come. Right, this is called force bearing ratio. So repeating again, that is proved only for two parallel forces. Right. Good. Okay, finish. Write down below with the red pen. Write down below with the red pen. Write down below with the red pen. Force dividing ratios are valid only for valid only for two parallel forces. Early 24, two parallel forces. Next point. Next point. If there are more than two parallel forces, 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 it should be simplified up to two parallel forces. It should be simplified up to two parallel forces. It should be simplified. It should be simplified up to. It should be simplified up to two parallel forces to use force dividing ratios. To use force dividing ratios. Okay. I'll give an example. See. Okay, here. What about? Take it slow. Example. Take it down. We can't use force dividing ratios to find the resultant of this kind of scenario at once. Not true because it's only possible for two parallel forces. No? But still, if we can simplify this system up to two parallel forces, if you can take this down to two parallel forces, then you can use. Then you can use. That is the idea. Okay, later I'll show this example before moving on. Finish. So as I told you, you can download the master questions of force equilibrium under week 5 October. Right? Last week under week 5 October. Right? Past paper questions, force equilibrium. Finished. Okay. See, now we are going to find the write down this as question. Find the distance. Write down. Write down. Find the distance. Find the distance. Find the distance. To resultant Find the distance to resultant from C. Find the distance to resultant from C. Find the distance to resultant from C. Right. Okay. Look at here. Our force dividing ratios. Listen, our force dividing ratios is applicable only for two parallel forces. Two parallel forces. Right. So therefore, I'm going to apply like this. If I just focus on these two forces, right? Doesn't matter any two. I'm going to focus on these two first. Look at the board. If I just focus on these two forces, applying this, by applying this, I can find the resultant value of these two with the distance now. Take the resultant just by using this. Take the resultant. From 10 and 10 resultant one. If there is 10 and 10, that is exactly in between. Right? That is exactly in between. Right? Otherwise, if you apply force dividing ratios, this is what happens. You can apply force dividing ratios just for these two and find the resultant of these two first. See? So let's say this is not the final resultant. Let's say R1, R dash, so R1 cube, R1. Then 10 and 10 means that is 21. Right? And if I find the distance to this point, say G1 at once, I can find BG1. See, if I need BG1, BG1 should be distance between these two forces. Now I'm going to consider these two, only these two. Only these two. Then distance is 8 over resultant 20 into, if I need BG1, other force 10. Simplify this. So it comes to 4 meters. Which means this distance is 4 meters now. 4 meters. Now, resultant of these two means this is the single force to replace these two. Then how many forces remaining in the system? Only two. R1 and 40. R1 and 40. Right? So if needed, you can draw the system again. Now, only this is remaining now in the system. 40 is not even touched. That is not simplified. That is there. Let's see. Right? And R1 is replacing, R1 is the resultant of 10 and 10. So R1 is replacing 10 and 10. R1 next somewhere here. What is the value? 20. 20 newtons. Right? And distances are now 16 from here, 16 from here, and this part is just 4. Something like this. Okay? Now you have narrowed down the system. You are taking down the system to two parallel forces. Then finding the resultant of these two is again one step away. Got it? Find it out and tell me. What's it? Huh?
Last year, everything.
Yes. So that is the idea. If you can take it down to two parallel forces, then totally fine. You can simplify. Okay. Say you have 4 forces. You can apply this multiple times and take it down. Up to you, totally up to you. Okay, either way it works. Either way it works. And the other thing is, listen, the other thing is, without applying force dividing ratios, now this the application of force dividing ratios. Without applying force dividing ratios, you can apply the principle of force moments at once. Okay, come on. Right? This is just to give you an idea about if you really need to apply force dividing ratios for such kind of scenario, still it is doable if you can take it down to 2. Right? So without doing this, our principle of force moments, there is no restriction as to forces, nothing. Right? So it works for everywhere. works everywhere. Right, my pen. First, tell me the answer from this. Do you mind if I change this value for the better simplification? For an easy simplification? The ones who have done already? Right? For the ease of simplification.
The gravity is from 20 Newton to
11. Sorry? Sorry?
is from 20 Newton to 30.
Sorry?
It's from 20 Newton to 30. Gravity just will
And now that's right. Wait a minute. It was not a decimal number with 3, that's why I changed. Right? Now 15 comes from. Alright? Alright, 15 comes. Alright. What's the revised answer now? Huh? 10 meters from C. 10 meters from C. 10 meters from C, I don't think. Because clearly I can see the various side is 40. Right? So it should be also 40. Online? Any answers? I haven't marked the final resultant here. Right? It is somewhere in between. Right? Something like this, no? It is somewhere in between. Final resultant. Right? Huh?
It is from B. With G1.
It is from B.
G1.
From G1. Then convert it to the.
It's from
Ask
C to
her.
5. The distance is asked from C to the sun.
From 0 to result.
5
So
meters from
directly I am going to find CG. Alright?
CG is 5 meters.
That's the value again. 5 meters. CG. I need CG. Distance. Yeah. This resultant is 20 and 40 means 60. Right? That is 60. This resultant value is 60. See? 60 newtons. Alright, we need CG. We need CG. Right? CG is total distance between these two is 50 over resultant 60. Right? If I need CG, you have to multiply it with the not connected force 20. Right? So that is 5 meters. That's all I'll ask. 5 meters. 3 meters. You mean from C? From C it cannot be 3 meters. Take whether you are referring to a different point. I asked from C, that's why. I asked from C. అవసరం లేదు జనరల్ లేదు 5 meters. Okay, good. Now, as an alternative method, see. So just after this thing, we are moving on to the first type of application of center of gravity, right? So that's why you need to understand this. That's why I'm spending much time, some more time here, because first type of center of gravity applications are based on this first force-unity ratios. Okay, first type. As an alternative method, you can do this as well. Apply principle of force moments. Right? Principle of force moments. So what was given? Right? What was given? This thing was given 40 newtons. 10 newtons. 10 newtons. 10 newtons. 8 meters. 8 meters. See? And 11 meters. This was given. Right? ABC. And I asked the distance to resultant from C. Right? So mark the resultant at once. Here. We don't know where. Somewhere here. What is the resultant of all three? 10, 10, 40, 60. 10, 10, 40, that is 60. Since I need this, so let's say G, right? Or else, if you are familiar with something like this, put L O X or something like that. That is also fine. Otherwise, if you can write CG, that is also fine. Right? Now, since I need distance from CG, I'm going to consider point C as my chosen point for force moments. Right? All forces are rotating in anti-clockwise direction about C. Got it? So in this side, I'm going to write the force moment using resultant. Right? Force moment about C from resultant due to resultant are 60 times CG. Right? 60 times CG. Right? And when we consider C, 40 is not contributing. 40 is not contributing. Right? By 10, there's a force moment coming in the same direction. 10 times. What's the value? 11. Alright? 10 times 11. Plus, there is another force moment comes. By this 10, 10 times 90. 90. Right? Total distance from C. Try simplify this and see. 1 0 to 0 to 0 cancels. Isn't it? Right? 6 CG equals 11 plus 90. 6 CG equals 30. CG equals 5 meters. That is also fine. Right? That's why we have multiple options. If you really need to use force dividing ratios, the true force dividing ratios, this is how we should apply. Right? If not, this is working, this is valid for any system. Right? Doesn't matter the number of forces, whether they are parallel, perpendicular, doesn't matter. For any number of forces, this works. Because when you write the force moment, you have to consider the perpendicular distance, then it adjusts and it works. This is right for any system. That's the principle of force moment. Right for any system. Right? Take this down as an alternative method. So therefore, if we have like more than 4 parallel forces, 4 5 parallel forces, this is linear. Right? If you do this, at once the answer. Right? Okay, take off. Now I hope you understood both methods better. Right? Make a volumetric value. This is for any application. This is a general principle. But this is specifically proved. This thing is specifically proved only for 2 forces. Because for 90% of questions, here we are dealing with center of gravity. You are dealing with 2 forces. That's why. That's why we are using it as a proved result. There are more than 2 forces. You can go with this. It is easy. Alright. Okay. Any questions up to this point? Any questions up to this point? Online?
I can play.
Go.
I speak like
Before 5:55, starting at 5:55.
2, 4, 5.
Go 5:52. Okay. 43. About the direction, about C. Because force moment decides the rotation, right? So if you need to listen, especially the new batch students, especially the new batch ones. If you need to find the direction of force moments, right? Imagine that you are keeping a finger here. Here means the considered point, and try to drag this by the required force, right? Try to drag this. Imagine you are dragging the system by the force. See, once it is dragged, it rotates this way. Now, if you drag from this force here, so it rotates this way. It rotates this way. That is the direction of force moment. Correct. Is it clear now? No. Why? Now, how it is going to rotate the other way if the drag is downwards from this? See? This is only rotation. Anti-clockwise. Dragging from this force, the required force. Something like this. Now, if you drag this point, say point O, with this force, see, with this force you are dragging. Force is acting downwards, working downwards. So it is rotating this way only. There will be only one direction from one force. Right?
Yeah, you can take this diagram value. Something that's. And then that way,
No, I didn't say this equilibrium.
no, we can take certain to the opposite side, so
Then you will get minus 4, minus values. Because this is the resultant of 3 downward forces. The resultant is also going to be downwards. Resultant of 3 downward forces. That's it. Right? And for new batch students, you have force equilibrium again. So there you will see the other applications of force moments and everything. I mean, you will be doing it again during the month under force equilibrium about force moments. Right? Okay. Any other questions? Okay. Right. Listen. Now here onwards, listen. Hereafter, we are going to start the first type of questions, first type of applications of center of gravity. Right? And then there are a few more theory parts. Right? After discussing one example application from this thing we learned, we are going to the remaining theory part. We are going to the remaining theory part. Right? Okay. Now it's 546. Since there are Muslim students, they need to pray. So therefore, we are going to have the break. Have the break of 10 minutes. 546 to 556, right? Okay. For online students also, if there are Muslim students who are praying, you can go pray and come. And the others also, if you need to refresh yourself, have something, have some snacks, you can just go back and come back in 10 minutes. Right? Okay.
it's all.
Now it's 547.
Yeah.
Okay. Others, if you are staying the meeting or if you have any questions, you can ask and verify. All good? Right. So we'll start. We'll start. Sorry, no, I was muted because then I was muted. I was working with someone else. That's why. Right. We'll start. Okay. Okay. Right. Listen. Hope everybody is back. Okay. Right. One more thing I forgot to mention that I'm planning to start the paper class for 27 batch as well. Right. As an online paper class. And just a plan we have now. I'm planning to start probably by December or latest by January. But December we are starting the revision classes as well. Therefore, with the revisions, but I didn't find a time. I might have to wait to January, right? So latest by January, we'll start, right? An online one, I'll be sharing all the details about the class, the channels and groups, right? So therefore, what I need to say is, since you are going to start writing papers, right? Main purpose is making you on track with all the things you are covering. Because now, since that is my paper class, you are getting questions only up to the point that we are ongoing. Now, let's say now, center period is ongoing, so you are getting questions up to the center period. Like that. The next month, if you are doing fiction, so questions up to fiction. So likewise, you will be doing in that same order. Our main purpose is first thing keeping you on track with all the things we have covered, and the other thing is practicing writing questions and understanding your current level. That is very important. Understanding your level is very important, even if to improve or further improve. Right? If you think that no, I can do, but if you are seeing that, if you are understanding that at the exam itself, that is not going to work. Because what a recovery period done, I mean recorrection period done. Right? So therefore, the main purpose of writing questions is that main purpose understand your current level and making you very solid with the knowledge from the parts we covered before, right? And finally, evaluating yourself. That is actually an evaluation. Because just by knowing ANAs and just by knowing the questions we discussed, we have discussed in the class, that doesn't mean you know everything. Right? Always questions are going to be different from one another. That is how it is. That is how the nature of the subject is. So therefore, higher the experience that you have about questions, right? Much easier to tackle a new question, much easier to approach a new question. Right? That's the idea. So that is why I'm planning to start your one much earlier. Now, actually, for 26 batch, elder batch, senior batch, I started to get class last October. Right? And now for you, the inquiries also came, but not the inquiries, but then I thought that starting a little bit earlier to make you more comfortable. First, the EVs, questions and everything, and it will support you to all term test anyway. Because in the term test you are getting up to the covered pass. Therefore, in the first year means in first months and the first period, it will be a huge support for the term test. And finally, and the ultimately it will be converted to the physical game class as the 26 batch. But after maybe around 7-8 marks, right? For the initial to get the start, and then the annual line to get the start, right? That is fine with you or not? Otherwise, I don't think actually you need to sit here spending some time on transport and all that. Just to write a see first term papers, no? First term in the 1 hour, 1.5 hours, probably 1.5 hour paper, right? But sometimes you need to spend more time in the bus, right? So you how long it takes from 5 minutes? Half an hour. Right, half an hour. Not 1 hour. So yeah, initially. This is the point initially. I am planning to start this as only an online one, and then we'll be starting the same as the 26 batch. So actually an improved version of 26 batch. Now for 26 batch, now what they are doing is they can write papers physically, come to the institute, and their paper is handed over, and then it is corrected and marked. Papers are graded, and the graded papers are given on the next week to them. And meanwhile, on Mondays, the discussion of that PG paper is happening from 6:30 to 9:30, 10:30. As an online discussion, right? That is how it goes. So physically, they get the paper, even if there is an online student, they can get graded papers. Online papers are also graded. For online ones, there is an allocated time on the website to write the paper. So they can write and submit. So once it is submitted, we can download from mobile and we are grading the paper. Okay, right? That is the ultimate plan. Now, since we are starting much earlier here, my initial plan is discussing questions, writing question papers in the class itself, right? To make you comfortable with the questions from the covered theories, right? That's the plan. But there will be other papers, right? Young questions, no, it will be other papers. Simply 25 MCQs, you are getting 25 MCQs in first term and second term. And then after third term, you will be getting 50 MCQs as in the exact format, the exam. In first two term best, you are getting 25 MCQs only. So therefore, you will be also writing papers with 25 MCQs and 4 essays. Two structured essays, 4 essays. That's the format. The format right? But I'll be discussing all the questions you in the class itself. Something like that. Right? Now, in the initial period, don't think about the timing. Right? Timing is not the thing. First thing is accuracy. Accuracy. And the approach. Right? Now, if you can do the question, just in timing is easy. Now, if you know nothing how to do the question, there's no point of it. No. That's why. Initially, not to do something correct. To approach the question in the proverb, to do something correct, to apply an equation in the proverb. Those are things. Right? Timing in grade 12, don't think of time. Timing will automatically adjust once you are familiar with the questions. You can come because once you are familiar, you are doing the question anyway. Then your timing will be automatically adjusted. Right? So that's the main focus I have. Right? So I think I didn't inform you last week. And I was actually thinking, I was thinking to inform my guest, but I think I got okay. So that's it. Dates are not fixed yet, right? Yeah, just the initial plan and figure it. Okay. Okay. Question 1. This is actually an example question. Question 1, no? Right. Question 1. Write down. Write down. 3 identical books. 3 identical books. Three identical books. Three identical books of length. Three identical books of length. Twelve centimeters. 12 centimeters of length. 12 centimeters each. 12 centimeters each. Are kept on a table. 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 As shown. Are kept on a table as shown. The student tries to. The student tries to. The student tries to move books. Move books. Move books away from the table. Move books away from the table as far as possible. Away from the table as far as possible. Without making the system unstable. Without making the system unstable. Without making the system unstable. Label this point as point X and label this point as point Y. What is the maximum horizontal distance? What is the maximum horizontal distance? What is the maximum possible horizontal distance? Sorry. What is the maximum possible horizontal distance? What is the maximum possible horizontal distance? What is the maximum possible horizontal distance between y and x? Between y and x. What is the maximum possible horizontal distance between y and x? Without folding books. Without folding books. Without folding books. Okay, take it down. Take it down. Don't do anything, just take it down. Finish. Okay. Look at here. Look at the board. There are three identical books, right? Which means their weights are equal. Weights are equal. Lengths are equal. In each and every aspect, they are equal. That is what is meant by identical. Right. Now, in this kind of a scenario, now can you first understand what I said? There are three books. One upon another, right? One upon another. And these three books are going to be moved this way as far as possible away from this point X. But without folding the system. Okay. From table. I mentioned from table. As far as away from table. Right? This is a table. This is a table. Right? Then them books move make the run only. Can you imagine what I'm saying? Give me three books. Yeah. Three identical books. Identical. See, now here we have three identical books. Table and kept on a table. Right? Now, if this book is moved, this can be kept without being unstable now. Right? There is one point that we can move all three and have the maximum distance between these 2 points now. Right? X and Y. That is what I'm asked. මෙයාව move වෙලා දෙන්නත් ඕන මෙයාව move වෙලා දෙන්නත් ඕන එහෙනම් unstable නැතුව තියෙන්නත් ඕන without making the system unstable something like this right so we need to find the distance from this table h to this point got it මේක තමයි කරන්න hey listen now listen this is the first question you are learning here in center of gravity. Right? So in such a case, always we are starting balancing from the topmost object. If you have multiple objects, first think about the top object, topmost object. If you have multiple objects, right? If there is just one, you know, center of gravity and acting line of weight should be inside the water, right? If I need the maximum distance, maximum I can take it up to neutral point, right? Maximum is neutral point. Without falling, see, if there's only one object, this is the learning I'm going to have from that neutral equilibrium. If there is only one object, without falling this, the maximum elongation I can have is when center of gravity is at the edge of the supporter. Right? From the previous thing we learned.
Take the topmost object to the neutral point and then take the second object, obviously the distance.
No.
Yes. The second one.
When you are coming to the second one, no, be patient. Okay. See, this is the idea we are going to use. Right? This is the idea we are going to use. It is clear. If there is only one object, right? There is only one object, and if you need to elongate it further, which means the last point you can have at the equilibrium is neutral. That is a neutral point. So this is the idea I'm going to use from those equilibriums. Right? Now I said you to start from the topmost one. Right? Since this is the first one, I'll be drawing another diagram. Right? Otherwise, now when you are familiar with this type, is the question type we have. Once you get the root next equal row, you will see there are more questions from this type in the root. Right? Right? Cool. Huh? See, starting from the topmost one. Look at the board. This is the topmost one. Okay. To balance the topmost one on the second book. 1, 2, 3 1, 2, 3. To balance the first book on the second book, what is the maximum elongation that I can have for the first book? Exactly half. Because we know center of gravity of this book is a uniform book. So center of gravity of this book is exactly at, say its rate is W, mg or W, anything, say W. We know center of gravity is exactly at 6 centimeters. Center of gravity is exactly at 6 centimeters. Now, if I keep the first book on the second book, as second book is like this, as the second book is like this at the edge. Now, does this fall? Does this fall? Does the first book fall? No, online. No, that doesn't. That doesn't fall because there is a neutral equilibrium. There is a neutral equilibrium. Now, if I think about now the first book is stable, right? First book is stable, right? Now come to the second book. Where do we have the center of gravity of the second book? It is at its own center. Same W, and it is 6 centimeters from here. It is 6 centimeters from here, right? And now this book should be on the third book, as both of them are stable. Second book is stable because first book is already on the second one. So when we think of the stability of the second book, book 1 is already in the system now, right? So therefore, now how many forces are acting on book 2? How many forces are acting on book 2? two forces. Because if there's another object on an object, that weight is definitely coming onto the object below, right? If something is on our shoulders, we can feel the weight of that other person. Same thing. Now, weight of this thing is acting at this edge of the second group. Let me extend this. Weight of this one is acting at the edge of the second group. So, by now, for second group, there are two forces, two W's, W and W. It's one W and the first group's weight, right? Both of them should be balanced by second group, right? Now, therefore, first what I'm going to do is, I'm going to find the center of gravity, anyway, I'm going to find the resultant of these two. Resultant of these two, right? The resultant will work somewhere in between. And that is the resultant force as a single force which acts on book 2. If that resultant is inside the border, it won't fall. Because that is going to be the resultant weight of these two. Resultant weight of these two. Got it? Therefore, this is where force dividing ratio is coming into play. Now I have two parallel forces, W and W. See, now I'm going to assume that the resultant of these two, resultant is 2W. Right? That's here. So let's say this is L1, right? If I need L1, this is the application of force dividing ratios. See how it is used in a question. If I need L1 can be written as total distance 6 centimeters over resultant 2W into not connected one W. These two cancels. L1 equals 3 meters, 3 centimeters. 3 centimeters. Got it? Which means when this equals 3 centimeters, resultant of both of them are at here. Resultant of both of them are at here. Right? So this is actually the resultant center of gravity of the second book. Because when there is another object on the top, mass changes. When mass changes, its center of gravity changes. Right? Now, when I am holding something from this hand, my center of gravity changes. Because of this weight. Same thing. Now, resultant center of gravity of book 2 is here. Right? For your clarity, let me label this as G1, center of gravity of just one. One ke vitara. Right? This is G2, center of gravity of both of them. Center of gravity of both of them. Because may force is factored here and this force is already factored here. So this is center of gravity of both of them. Right? So if that center of gravity is at the edge of the border, the system of two books won't fall. Got my point? If that center of gravity, because this is resultant weight now. If that resultant center of gravity is at the edge of the border, right? If I consider both of them as a single system now, it won't fall. Got it? So therefore, third book should be kept like this, isn't it? Does it fall now? Does it fall now? No. First two books are balanced now. Right? First two books are balanced. This resultant is here. Now, may I support a medical? So that is at the edge of the border. This is a border. So that is at the edge of the border. Got it? So it won't fall. Now go to the third book. Go to the third book. Center of gravity of third book is at its center. Right? At its center, W. That is also 6 centimeters from this edge. Right? Now for the third book, already a force of 2W acts at the edge. Already a force of 2W acts. Right? Then I'm going to find the resultant center of gravity or the resultant going where resultant weight acts. Right? W and 2W. That is how our force dividing ratios comes into play. Say resultant of these two, 3W acts at this point G3. Right? And I'm going to find this out. Say L2. Right? How to find? L2 equals total distance between these two forces still 6 centimeters. Right? For W and 2W. This was for W and W. This is for W. And here I'm using this for W and 2W. then resultant is 3W times I need L2. Here we have W, not connected force, W. 2 centimeters. 2 centimeters. Which means this resultant center of gravity G3. G3. Now when I'm coming to G3, 2W and W are considered. 3W X here. 3W means this is the total weight of all three books. Which means when I'm at G3, that represents all three books. Which means G3 is the center of gravity of ultimate center of gravity, common center of gravity of all three books. Got it? Because weight is 3W. 3W acts at that point. Then center of gravity is the point where weight acts up. Then resultant center of gravity is the point where the resultant weight acts. Resultant weight is 3W, 3W acts here. So this is the center of gravity of all three books now. At this point we have the center of gravity of all three books. Right? All three books. Now this is also balanced. This is also balanced. If the table was like this, resultant one. If the table is like this, the system won't fall. This should be at the edge of the table, isn't it? This should be at the edge of the table. Right? Now it won't fall. Now it won't fall. Book 1 is balanced, book 2 is balanced, and now book 3 is also balanced. Right? Now at this point, when you consider G3, all the books above, all the objects above are automatically balanced now, because we have factored with 2W here and we have factored 3W here. Right? So therefore, all the books which are above are already balanced now. That is why we are approaching from the top. Right? So if you have multiple objects, you have to approach from the top, one by one. Then when you come down, automatically, objects, all the objects above are balanced automatically. Got it? Now this is balanced. So therefore, distance between x and y, Lxy, let's say, distance between x and y is, point x was here, y is here. Right? L2 plus L1 plus 6. L2 plus L1 plus 6. What's that? 5, 11 centimeters. See, that is the thing. Correct? You can't just imagine how this is going to be in equilibrium and find it out. You have to do the calculation. So in the calculation, this is how force dividing ratios are used. Right? That's why I told you. For type 1 and for next type also force dividing ratios are used. So that is why we have proved force dividing ratios for two parallel forces. Because in most of the cases, you are getting two forces only. Right? This is the first type of application you have. Got it? Right? There will be more questions on the route. In the route, you will get next day. So I discussed this just to get the start. So this is how we do. Right? You come down the then on our put maybe done the should be calculated. Now this is what you should understand. G1 represents center of gravity of, tell me. G1 represents center of gravity of book 1. G2 represents center of gravity of 1 and 2. G3 represents center of gravity of 1, 2, 3. Got it? So that is why now resultant center of gravity of the system is KW. So system is balanced because there is at the edge of the ball. Got it? That's the beauty of physics. This is the same thing used. Have you seen? Have you seen the stone structures like the curved ones? No, make it okay. Stone structures. Right? I come pass again. Any questions? And principle behind balancing objects is that about stones, right? So when stones are balanced, this is the principle behind. Right? But polymer stone that is at the neutral equilibrium. Correct? All stones are we have a structure. Right? Got it? Not calculations. The principle behind those equilibriums are right now when we are placing stones one another, we have to make sure that center of gravity inside the support surface? If yes, it doesn't fall. Right? If slips, it falls. You got it? Pyramids. In pyramids? No.
There's support not very.
Same shape.
Yeah, it is true. But from all four walls, they are support to each other, so therefore it's given. Now, from this wall is supported, right? Mutually supported. At the vertex. Therefore, there is no case, not the exact case. Right? Okay, any questions on this? Now, even though this is the first time, there is something to understood. Something to be understood. Right? Any questions? Over? Online students, are you clear? Any questions? Are you clear about this? So this is how we make use of neutral equilibrium. And this is the theory I used. See, this is the theory I used. Right? If it works for one object, it should work for a system as well. Same thing. That is the theory I used. Clear? Put a thumbs up. Clear, clear. Okay, good. Okay, good. So if any questions, you can ask before leaving the class. Right? Take it down. So this is the theory. And the theory start balancing from the first one. Start balancing from the first one. And always center of gravity should be at the edge of the border to get the maximum elongation. Right? To get the maximum distance. Last point of equilibrium is neutral. That's why. Good. Compared to other parts in mechanics, center of gravity is kind of an easier part. Right? Do the calculation by your own by understanding this. Right? So one by one, I have done the calculation one by one. Balancing the first one, balancing the second book, balancing third book. Right? Usually you are getting 2 or 3 objects. Right? Usually you are getting two or three objects. In my cute, I have put a question from 4 objects as well. Right? But from 4 objects, it has not come with H3 yet. Right? 2, 3 objects are more frequently coming. Right? But if we need to practice, I have put a question with 4 objects as well in the report. ආර්කම් මේක දිහා බලලා මේ 2 cm කියලා මම කියන්න පුළුවන් අර දැන් ඔක ඉවරේ ඔක කරගෙන ඉවරද අද ජීසත් මේක කියන්න බෑ මේක දිහා බලලා 2 cm කියලා බලලා කියන්න බෑ just by looking at it can you say it's 2 just by looking at this can we say that it's 3 do the calculation මේක පුළුවන් first one පුළුවන් ඒක බැරි නම් ප්‍රශ්න right first one මේක පුළුවන් because there is only one book, no? There is only one book. If you have more than one object, we can't just imagine, right? You have to do the calculation. If they are unidentical books, it is a little bit complex. Made a little bit complex compared to this. If they are unidentical, you will see those ones also. That you, right? මම කෙලින්ම 4 objects වල non identical එකක් පික් කරලා තමයි දාන්නේ. අතන non identical නෑ. ලස්සන එකක් තියෙයි. Okay. All good? Okay. Questions? Right. Mention these points in red. The question. First point. First point. Start considering. Start considering equilibrium from red pen. Red pen. Red pen. Start considering equilibrium from. Start considering. Right. Start considering equilibrium from topmost object. Start considering equilibrium from topmost object. Second point. Second point. Neutral equilibrium should be considered. Neutral equilibrium of books should be considered. Neutral equilibrium of books should be considered. Neutral equilibrium of books should be considered to get the maximum elongation. Neutral equilibrium of books should be considered to get the maximum elongation. Neutral equilibrium of books should be considered to get the maximum elongation. Right. Next point. G3 represents G3 represents G3 represents center of gravity of all system of free books. G3 represents center of gravity. To write center of gravity, you can write COG, right? Right? Without writing center of gravity, you can write COG if needed. Right? Then throughout the lesson, you will write this now. Topic again, throughout the lesson, you will write this down. In the note, when you are writing center of gravity, use COG. Capital.
Capital G.
Ah.
Capital CON.
Ah. Malakian berkawan itu ada Malaysia center of gravity. Because that is your own note. It should be clear to you. Get note, right? Okay, one thank you.
Whole system of
Center of gravity of whole system. Center of gravity of whole system. Okay.
G3 represents center of gravity.
G3 represents center of gravity of whole system of three books. Center of gravity of whole system like a system of three books. System of three books. Right? G2 represents. Next point. G2 represents center of gravity of system of two books. 2 means 1 and 2. G2 represents center of gravity of system of 1 and 2 books. 1 and 2 books. 1 and 2 books. Therefore, listen. Therefore, if a system is in equilibrium, which means part by part also it should be in equilibrium. Right? So that is why this happens. Book 1 should be in equilibrium. Book 2 itself should be equilibrium. Book 3 equilibrium. So as a system, if I consider 1 O, 1 and 2 O, 2 and 3 O, all 3 O, whatever the way, it should be in equilibrium. Got it? That's the point. Okay. So these are type 1. These are type 1. Balancing questions. They are all balancing questions. Balancing using center of gravity. Right? So you can try this out at home. Take 3 identical books. And boxes are better than books because sometimes when you try to do this using books, in reality, if the book folds, right? If the pages turn, there is an impact. Right? So if you have identical boxes, right? Identical boxes, you can do this nicely. You can try it out. Right? But the thing is, when we are doing this practically, you have to do this from the bottom. Calculation is done from the top. But when you are keeping, it falls. Right? So therefore, you have to keep it from the bottom. Like this. Right? Give it a try. Okay, keep this heading written. Center of gravity of a symmetric object. Next heading. Next heading. Center of gravity of a symmetric object. 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 Okay. So that is where we have to start next day. Center of gravity of symmetric object, and few theory parts are coming up, and more question types are coming up. Right? When it comes to the center of gravity, you are not only having calculations but also more arguments are coming. Right? Different shapes of objects can be given, and you are asked to guess where the center of gravity is. Argument type questions are very popular from center of gravity. Right? We'll see all the things in the coming weeks. Right? All right. So, what about the lesson today? Any questions? All good. Can do any center of gravity question from balancing. Okay, so next day you'll be starting off with 2 balancing questions. Right? So go through everything and come to the class, because next day I'm repeating again. We'll be starting off with 2 balancing questions to recall this and go to the new theories. Right? So everything that we learned from the beginning to here, right, will be needed for all the questions, and there are few more theory parts also coming up in the other parts. Okay. It's posted today. I think it will take 2 to 3 days. 2 to 3. So before Tuesday, it's coming, because in your case, you are getting 2 duties for Tuesday class and this one. So both are coming together. So it will come before Tuesday. Right? All right. Any other questions? All good. What about the lesson? Online students? Any questions? Did you understand the lesson? Did you understand the lesson? How was it? Center of gravity. Yeah. Okay. Right. All right. Then there's no questions. We'll add up. Right. So in the coming weeks, we'll be spending all the weeks with center of gravity. So there are more weeks coming up. We'll be spending the weeks with center of gravity. Right. So on Tuesday, for the Tuesday batch, new batch, we are starting. We have started Newton's law, so we are studying the applications of Newton's laws. Right. We are studying applications of Newton's laws. Go through all the things we covered there also before coming to the next class, and especially here about center of gravity. Go through all the things, because all these theories are needed for the question types coming up. Right? Okay then. Is it raining outside? No. All right. No. Right. Then we'll wind up here. Go safe and stay safe, and spend your vacation productively and effectively. Very important. Right? From my side also, I'll be conducting few discussions to take you to the lab. Right? And I think other classes also, sometimes schedules can be changed, and sometimes there can be extensions of the times, and everything happens. But from your side, you are the one who are responsible about your life, right? And your job. So therefore, from your side, you have to have discipline to work accordingly, as I explained at the beginning of the classroom. Right? So utilize the vacation more effectively and productively. Wherever you are now, when you are starting the vacation, don't ever think of being in the same level, same place by the end of the vacation. right? You should improve yourself. You should upgrade yourself. You should uplift yourself, right? For that, you have to work on that, right? So keep that in mind. Study hard, work hard, save all the extras, right? Good night and goodbye. Oh, yeah.